Okay, the last section that we're going to cover out of topic 3 is 3.5, and it's called scatter plots and lines of fit. And you can look through the definitions here. A scatter plot is just a graph that's used to determine whether a relationship exists between some paired data. So you can see different scatter plots here. When you get out and actually graph data from a real-world situation, you're typically not going to get a perfectly straight line. But you want to be able to look and see if there are some correlations or some relationships that exist between data. A positive correlation, if y tends to increase as x increases. What we're looking for with a positive correlation is a positive slope. So you can see this data is kind of going uphill. As the x values increase, the y values increase as well. And so that's a positive correlation, or a positive relationship. Okay, a negative correlation if y tends to decrease as the x increases. So if you look at this example over here, as the x values are increasing, the y values are decreasing. That's kind of a negative slope. It's going downhill. So that's what a negative correlation looks like. Okay, and then no correlation is if x and y have no apparent relationship. If you look at this middle graph here, the points are all scattered around. There's no tendency to go uphill, or there's no tendency to go downhill. They're just all scattered about, so that's no correlation at all. That's what they mean by that. So when it says describe the type of association, that's what we're talking about. Does it have a positive correlation? Does it have a negative correlation? Or does it have no correlation at all? When you go ahead and you plot your data points, remember you can adjust your intervals as you need to, depending on how large your values are in your data set. Okay, do that if you need to. Okay, now when we make a trend line, or what we call a line of best fit, it models the data in a scatter plot by showing the general direction of the data. Okay, so let's make a scatter plot and draw a line of best fit and write its equation. So this is what we're going to do. We're going to do three things. We're going to draw the scatter plot, we're going to make the line of best fit, and then we're going to write the equation for that line that we drew. Okay, so first off, I'm going to plot the data. So just plot your points. X is 1, y is 2. I've got a point at 2, 3. Got a point at 3, 3. Got a point at 4, 4. I've got a point at 5, 6. Going to be about right up here. I'm actually going to go off my graph here. 6, 7. See, that was 1, 2, 3, 4, 5, 6. If I go 6, 7 is going to be out here, and 7 is going to be about right there as well. So I did have to estimate a little bit because I went off my graph. But you can see these are not exactly in a straight line. Okay, but that's your scatter plot. To draw your line of best fit, you're going to want to take a straight edge. So if you don't have a straight edge, slide that little card out that identifies your computer. You can use that as your straight edge, but I'm going to use a straight edge here. And I want to draw a line through this, a straight line through this. And when I draw the line, I want to have about the same number of points above my line as below my line. Okay, so I'm going to adjust this a little bit. And I lost all my points. Okay, can't do that. Let me go back and let me graph that again. So I'm going to do 1, 2, 2, 3, 3, 4, 6, 6, 7, 7, 7. Okay, so you're going to adjust your straight line. But you want to draw that. I'm just going to try to draw as straight as I can. You want to draw a line through your points. Okay, and you want to have approximately the same number of points below the line as above the line. So you can see I've got a line up here, a point up here that's above the line. Well, I've got a point over here that's below the line. You want to kind of even it out. Now, all of our lines are going to be a little bit different, so there's no one exact right answer. But you want to draw a straight line through your points. And you want to, it's kind of the best representation of those points. Okay, so that's my line of best fit. Okay, and then lastly, I want to write the equation of that line I drew. If you go back to topic 2, when we wrote down the equation for the lines, what did we need to have in order to write the equation? Well, we needed to have 2 points. So you're going to pick 2 points on your line. I used the point 1, 2 fell on the line. And if I go up here, that point is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's supposed to be 5. It looks like 5, 5 is on the line. Now note that the points, this is actually off here a little bit, you want to pick points that are on your line. They do not have to be points that are in the table, but they have to be points that are on the line that you drew. So these 2 points are on my line. I'm going to find the slope of that line between those 2 points. So I'm going to say 5 minus 2 over 5 minus 1. I'm going to get 3 over 4. So 3/4 is my slope. And then to find my b value, I've got to use one of those points. I'm going to say y equals 3/4 x plus b. I'm going to use this point 1, 2. So I'm going to say 2 equals 3/4 times 1 plus b. 2 is equal to 3/4 plus b. So if I subtract 3/4 from both sides, b is equal to 1 1/4, or 5/4. So I'm going to say m was 3/4, b is equal to 1 1/4 is the same as 5/4. So my equation, okay, and I'm going to erase my work here. My equation then is going to be y equals 3/4 x plus 5/4. Okay, a little bit messy, but if I go back and kind of look at the line that I drew, it's saying that it's going to cross the y-axis at 5/4. Now that's approximately 1 1/4, and that's about right. Okay, it has a slope of 3/4, so if you count rise and over run, does it rise 3 and run 4? And it does. So that equation describes my line of best fit pretty well. Now keep in mind that since we're all going to draw a little bit different line, we're all going to probably be picking different points to use, and we're going to have different slopes slightly and different b values. So there isn't one correct answer. But what I'll do is I'm going to look at your work, make sure that the points that you choose are on your line when you found your slope. Make sure that you chose a point that was on your line to find your b value. And then I'm just going to check your math. So we'll all probably have different answers for this equation, and that's okay for this worksheet. Let's try another one. Okay, I'm going to plot this on the graph. And it's a little bit frustrating on that last one, how we kind of ran out of room. So I'm going to change where the axes are. I'm going to come down here and I'm going to say this is going to be my y-axis. And this is going to be my x-axis. And you're welcome to do that. If you're drawing your own graphs on your notebook paper, you can do that. Or if it's given to you on a worksheet, you can change where your axes are. Okay, now I'm going to plot my points. So I got 1, 7, 1, 2, 3, 4, 5, 6, 7, 2, 7, and I got 2, 5, 4, 4, 5, 3, 6, 3, and 6, 1. Okay, so there's my points. Okay, you can kind of see that they're tending to go downhill. That's a negative correlation. I would use a straight edge, and I'd lay that straight edge on there, and I would want to draw a straight line through there. Okay, so there's my line of best fit, and you can see I've got a point above the line and below the line. Got a point above the line and below the line. You want approximately the same number of points above as below, so that's a good average there. Now I want to write the equation to that line. So in order to write the equation, I've got to pick 2 points that are on the line, and keep in mind they don't have to be in the table. They just have to be on my red line. Got a point right here that's, for me, that's at 1, 2, 3, 4, 5, 3 is on my red line, and let's go 1, 1, 2, 3, 4, 5, 6, 7. 1, 7 is on my line. Those 2 points are definitely right on the line, so I'm going to use those to find my slope. I'd say 7 minus 3 over 1 minus 5. 7 minus 3 is 4. 1 minus 5 is a negative 4, so my slope comes out to be a negative 1, and that's a good Good sign I did my math right because it's a downhill, it's a negative correlation, so it's probably going to be a negative slope. I would say y is equal to negative 1x plus b, and I'm going to use one of those points to plug in and find my b value. I use this first point, I'm going to say 3 equals negative 1 times 5 plus b. 3 equals negative 5 plus b. If I add 5 to both sides, I get 8 equals b. My equation then, y equals, my slope was negative 1, and my b value is a positive 8. Okay, if you look at my graph, here's my y-axis, remember, these aren't my axes anymore, this is my y-axis, and I'm saying it's crossing at a positive 8. 1, 2, 3, 4, 5, 6, 7, 8. That's really good. That's 8 right there. And I have that slope of negative 1, so it's going over and down each time. So that's a pretty good accurate line there. That's what I would have, and my work supports the line that I have. It's going to be very important that you show your work on this assignment and when you do these questions on your quiz and your test, so that I can track to make sure that you've done things correctly. Okay, you're also going to get opportunities with particular situations where you've got something other than x and y. We're just using the top of the equation, no matter what it represents, where that's going to be your x and the bottom is going to be your y. And you're going to do the same thing. Now you'll notice that you got some different values here. Your x values are going all the way up to 60. So again, I would probably adjust where my axes are in order to use the graph right here. And then I'd choose, maybe go by 5s in the x direction so that you can fit 60 on your graph. Now for the y direction, you only have to go up to 6.65. So since you've got some decimals there, you might want to break this up and not go by 1s, but maybe go by halves or something like that. And you're estimating where those are. So you're going to plot these points on your graph. You're going to draw your line of best fit, however that goes. You're going to write your equation, and then you're going to use your equation to do some estimating at the end. Okay? If you have questions on that, send me an email or join our Zoom session. Go ahead and try that assignment.